Okay, all right. Hello everyone, my name is Gopal Singh and thank you so much for joining in for the day two essentials for machine learning from zero to hero. And okay, just a sec. I think I need to fix my Bluetooth here. All right. Okay. So let's start. Okay. So let's first, share the screen here. Okay. Now we can see. Let's see. Hello everyone. Hello everyone. Hello everyone. So how are you doing all? So hello Lanka. Hello Abdul. Hello Ashish. Ashish. Sorry. Hello Arun. And sir, can you tell yesterday's assignment? I think I have mentioned already. Like you'll be given an assignment on the day three. So on Wednesday, you will be having an assignment. Hello Vignesh. Hello Shashikant. Hello Mrinal. Good evening. Good evening to everyone. Okay, good evening to everybody who have joined today. And let's actually learn today, like, let's make something today, like, which can actually predict something, right? And let's start. Okay, so how many of you are excited about it? Let me know. Hey, Sanjay, what's up? Hey, Khatib. Hey, very good evening. Hey, Lanka. Okay. Hey, Anshu. All right. Yeah. Okay, so let's start. Should we? Shall we? Yeah, we should definitely. We are in a great place right now. So let's see, what the machine learning process actually looks like. The estimation process, or I would say the prediction process. Like prediction, classification, estimation. Like they actually require some sort of a different definition when we dig deeper into the machine learning concepts. But just for now, just assume like what we will be doing here, like we will be tackling a problem called iris dataset. Like it's the most basic problem that you would ever encounter. It is somewhat known as a hello world for machine learning in classification, right? You must have wrote a hello world program while you were in your 12th grade, or maybe in your first year or freshman year in your colleges, in your respective colleges. So that is the in the very same analogy, this iris dataset has a reputation of being a hello world program in machine learning, which we will just going to see. So, but how exactly, like what we exactly will be doing, let's see. Okay, what exactly we will be doing. Okay, let me just give you a simple checklist here. Checklist for you know model training. All right, what do I mean by the model training? Let me also give some sort of explanation about it as well. Okay, what exactly do I mean by that? To enable an algorithm to make some predictions. Okay, that is your model training. Okay, that is the most layman term that I could ever, I could actually, that this is the most plain English I could ever put it into, most simplest words. Like to enable an algorithm to make some predictions. That's it. Okay, that's it. That how easy it is. Okay, so let's like that was just the definition of it. Let's actually see the the checklist. First, you know, accumulate the data. Okay, second step will be know about the data. There is a zeroth step as well. Zeroth step is you know uh, explore the business problem, business or case study. I would say business study or case study. Don't worry, I will be covering each one of these steps. So just I'm just making a checklist for you guys. So whenever we complete one, we're just going to put a checklist, then like this and this. Okay, so don't worry about it. Okay, all right. Okay, so know about the data. Third would be, or fourth, you can say, it will be, cleaning the data, and then training the model. And the fifth or sixth one will be making predictions. Okay, and I want to give a disclaimer here, or a simple disclaimer here. These are not all the steps, honestly. In machine learning, we have around like 17 to 18 processes that we might have to, go through. Okay, which we will when we will be tackling a real world problem on Kaggle. But right now, like I'm just trying to keep things as simple as possible right now, for the sake of the people who have just joined maybe for the very first time. They are starting off with data science for the very first time, so I just don't want to confuse them at all. Or either of you people who may have some sort of maybe experience, but still wants to understand some things on on a basic level. So I'm just trying to keep things here simpler as much as possible. So let's actually go with the business case study. What business case study we will be studying about? Okay, so we will be studying about iris data set or task. Let me also write here task is to predict if a flower species belongs to versicolor, virginica, or setosa. Like whenever I put my, well, let's say I will be having four features here. I will gonna get back to that, task, sorry, the data just in a while. But let's say we will be having four features: F1, F2, F3, and F4. And we will be having a class here or a label. So based on these four features, I need to determine, or I need to predict, like if my flower is versicolor or virginica or setosa. That is our task, guys. I hope you understood the task fairly well. If not, please let me know in the chat. Okay, I will going to like I can actually reiterate. I can repeat myself. So okay, but if not, and let's actually proceed. If you have, then let's actually proceed. Okay. So let's see the data in in real time. Like what do I mean by that? The data, like how exactly we can see the data here. Okay. So firstly, I would like to write here, iris data set. First, actually, let's see like why we are studying about the iris here. Let's see like this is your iris data set actually. Okay, and let me open imagine new tab.
Hello.
Yes.
Sir, sorry to interrupt. Actually, students are telling to use whiteboard.
Oh, all right,
Yeah.
sorry for that, guys. Okay, I did not catch on that. Okay, is it fine now? Yeah, it seems fine now. Sorry for that. Okay, I almost forgot like about it. Sorry. Okay, so let's say okay. All right. So we do okay. So because there is no visible result, do we have to prepare the notes? Please change the screen color. Okay, some people are okay. Sorry for that. I literally, I was more, less. I was just totally into the about explaining the entire problem. But now I have converted into the whiteboard. Okay, so all right. So now, like this is the problem statement. Let's understand this statement here. Okay, like for this one, like if I hide these names, iris versicolor, setosa, and virginica, like it's almost next to impossible to tell like which one is which. Honestly, Like I cannot tell if I am a botanist or something, like if I have years of experience, I cannot tell but with my bare eyes for the very first time, like if it is versicolor, if it is setosa, or if it is virginica. For sure, I cannot. Okay, so that is your business problem. And based on what we can determine, based on what features, we do have to determine if a flower species is of a versicolor or of a setosa or of a virginica. Let's see. Like I hope you can see this, sepal and petal. Okay, so sepal is something, this part of a flower is a sepal, and this is your petal. So we have been given four features here, guys. Okay, those four features are sepal length, sepal width, petal length, and petal width. Sorry. Let me use the black one. Okay, so we have sepal length, sepal width, petal length, and petal width. Okay, we have these four features: F1, F2, F3, and F4. And based on the combination of these four features, I need to determine my class, right? And this is my class here. So if let's say hypothetically, assume it, like we have created our model here, which we will just in a while. Okay, this is our model. And if I take a set of, sepal length, sepal width, petal length, and petal width, and I pass this set to this model, it should spit out one of these classes. Right. Let's assume the class is versicolor. In this case, could be. Okay, versicolor. So these sepal length, sepal width, petal length, petal width were estimated to be a versicolor species. Like that is our whole task to achieve here in this session. Like we need to create some sort of a model, right, which can determine like if a species is of a versicolor or if a virginica or setosa. That's it. Okay, so our what was our first what was our like it has been covered. Now is the accumulating the data. Now let's actually get here, accumulating the data. So where can you get some data? Let's see. So as I just wrote here, iris data set. Okay, so just go on to this website, kaggle.com. I hope you can see it. Okay, like this website, kaggle.com. Go on to this link, and you will be redirected to this competition. So this competition is, as I have already mentioned, the entire workflow of of this case study or this business study. Like people at UCIML, they like maybe the botanists, they may have collected a lot of iris species, and after that they came up with simple like not simple but with those features like sepal width, sepal length, and petal width and petal length. And based on those four features, they are determining if one of the species is of a versicolor, virginica, or a setosa. I hope that is clear. Okay. So now what will be my next task? My next task will be to accumulating the data. So here is your data here. Okay. So just download it. Okay. And you can literally save it anywhere. Okay. But I have already saved it somewhere else. Okay. So what you can do, right? Like you can certainly download it, not an issue. But what you can do, you can also, like I have this data set as well. You can host a data over a cloud as well. Okay, so this is again a CSV file. Okay, this is again a CSV file, and this CSV file has some values. You can see sepal length, sepal width, petal length, and petal width, and this is your species. So the first value is sepal length, second is sepal width, third is petal length, and fourth is petal width. Okay, so if I pass these values, let's say 5.1, 3.5, 1.4, and 0.2 through my model, it should spit out this Setosa class. Okay, and this data is being saved as a CSV file here. CSV stands for comma separated value. And you can see for yourself, like these values are being separated by a comma. Like each value has been like is being separated by a comma, like here, then here, and here, right? Okay. So every value is being separated by a comma. Okay. And now we can literally read this entire data with simple commands. Let's do that. Okay, already. So to keep things simpler, I will not be using my local machine because it requires some sort of installation. So we will be using some pre-built environment right now, which is Colab in this case. Okay. And after that, we'll be better off with our basic case study, and then we will be jumping onto a more advanced one, but tomorrow. Okay. But in this one, I'm just giving a hint of hint of a machine learning, how does actually it works. So let's say for the collab, just go here and you can also follow along. Okay, I encourage you to follow along. All right, in this one only. Okay, do we have a questions? No, we don't. Okay, I think we are good. Okay, and now like iris problem. Let's call it iris problem. Okay, and just click on this connect. Sorry for cracking my knuckles. Okay. Meanwhile, it is connecting. I thought of cracking my knuckles. Okay, now we have connected our, this collab to, this entire environment to some RAM and some disk. And now we can start coding. Okay, so the first one, which I will be needing here are, some libraries. So import pandas as PD. Okay, and for this one, like, let me also write it here for data manipulation, for data handling, I would say. Okay, for computation, I'll be using import numpy and as np. Okay, for plotting, import matplotlib.pyplot as plt. Okay, so these are the libraries for the very basic libraries here. Okay, let's shift enter. All right, and now is the time to read that data. So df pd dot read csv, and let's pass this data's address here. Copy, and I will be just pasting this data's address here. So you can see like it's iris.csv. You can download it if you want to, but you can certainly read it like this as well. Okay, shift enter. Now let's run df.head. So what does df.head do? Okay, df.head brings out the verify first column or verify first rows of your data. So let's try to understand like what exactly, like what kind of a pat or what kind of a type of this data is, right? This is your pandas data frame, and pandas data frame especially is for machine learning tasks. Like we can use like for pandas can be used for other tasks as well, but broadly it has been used in data munging and data wrangling. So basically for the data analysis as well, like that's where it also being used heavily. But right now, let's actually not get into that. Okay, so now what we are doing, we are basically reading out some data from this very link, and now we are spitting out verify first rows here, which in this case like these. Okay, and right now this data is somewhat has a array values of sepal length, sepal width, petal length, and petal width. Let me show you how can we extract that array value. Okay, so let's see. If I do this df dot values, it will going to spit out. What just happened? Okay, Yeah, there you go. Okay, so it will just going to spit out an array of all the values. So you can see, right, for the for the very first row, like this one, this is the same row, right? 1.4, and but in this case, it has been somewhat structured in a better way. Okay, and like right now it is like you cannot read it like which one is which. Like I cannot tell like if it is sepal length to sepal, petal length or petal width. But in this format, I can read it more efficiently. So it also enhances the readability of your data as well. Okay, so that is why basically we use pandas data frame. So not only for this, we can also perform some data manipulation tasks as well. Okay, and also you can run even SQL queries along with this pandas. So it's quite versatile when it comes to dealing with the data. So do check it out. It's do check out its documentation for the further quench your thirst for the data analysis or data maybe in terms of only pandas. But right now we are better off with this only df dot head. Okay, so what does df dot head do? Like this only brings up these 5 rows. Okay, and these 5 rows are nothing but an array, or I would say specifically a numpy array, which has these values in it, right? Okay, and now let's say now the next task. So where exactly we are, we accumulated the data here. Okay, and now know about the data. It is now the next task of ours. Like how can we know about our data? Let's see. Okay, it is our next task now. Okay, sorry for that. Okay, so I will just going to remove this. So let's you can also give some headings here without an issue. So just pass here uh, know your data. Okay, so I will be performing a simple two commands here, df.info and df.describe. I will going to describe what each one of these, just in a while. Okay, let's see like how exactly we can know our data. For this one, I can tell for this one, like I have range index of 150 entries. So I have total 150 values in my data set. Okay, 0 to 149. Okay, and sepal length has a data type of float 64. Okay, it is a more of a continuous value. Okay, decimal values you can say. Same goes for this and this. And I can see here like I don't have any missing values, no missing values. How can I say that? How can I say that? Because I can see here like the entries which are being shown here are 150, and I have all 150 non-null values. Non-null means not missing. Okay, and this is a species, and this is more of a string object, guys. Okay, like string object, what do I mean by that? They have given a label. They have given a label in this format, like versicolor, virginica, and satosa. Okay, or obviously, if you are familiar, like I believe so, like you may have coded a little bit in Python. Okay, not in if not in Python, so in maybe in some languages, right? So this representation is of a string. Okay, and this is your string object in this case. All right. Okay, so this is your like so basic info about like how much data we can actually see, maybe in terms of data type and also in terms of how many data we might or might not be having right now in our entire data set. Let's scroll down a bit and see the df.describe though, like what exactly it tells us. So let's actually see for the sepal length. I am just writing here sepal length here, guys. Okay, and I will be making like I'm just taking this column here, this one, only this one. Okay, so for this one we have count, and the count, like I can see like count basically 150 values here. Like I have 150 sepal lengths in my data set. First, like it was so easy. Mean, what does it tell us? Like mean is an average value. Like on an average we have 5.8 centimeter of sepal length on an average. It's an average value. So I highly recommend you guys, I highly encourage you to write each observation in your own language, in maybe in plain English. That's it. Standard deviation. So standard deviation, like how much it actually varies from the mean here. So if I have mean of like let's say 5.8 centimeter and a standard deviation, has a value of 0.82 centimeter, so it will going to vary for like 5.8 plus minus 0.82. So it could be 5.8 plus 0.82 and also 5.8 minus 0.82. That could be that is your sepal length. Minimum value of sepal length that we have here in this case is 4.3. Minimum value, right? In this entire column, in the entire column of your, sepal length, we have a minimum value of 4.3. Here, what exactly it is? These values are percentile values. These are your percentile values, guys. Okay, let me write here about something like 25% for 5.1. What exactly does it tell us? Okay, let me actually create some new space. Okay, let me actually let me actually put it here. 25% of 5.1. So what does what does it mean actually? So I can like let me actually write it in plain English. 25% of my sepal length has a has a value less than 5.1 centimeter. So let's actually plot it out on a simple line graph. Let's say we have this line here, and let me divide this line into three parts. Like this is your 0th percentile, 25th percentile, 50th percentile, and this will be your 75th percentile, and this is obviously your 100th. Okay, for 25th percentile, I could have these value here, 5.1 centimeter, and this will be a 5.8 centimeter, and this will be a 6.4 centimeter, and of course like 7.9, 100% values. So what I can say, like all the values which lies here will be less than 5.1 centimeter, and the range for that is 25%. Like 25% of the data is less than 5.1 centimeter. Simple percentile value. Okay, same goes for like, but of course with different observation, you can make the same statement with a different observation, for the 50th percentile, also for the 75th percentile, and also for the 100th percentile, easily. And the max value, like what is the maximum value you are having in a column? Well, in this case it's 7.9 centimeter. So 7.9 centimeter is the longest sepal length that we can have in our data set. Is it clear to everybody? Okay, let me know if there are any doubts. I think I should actually see here. Can you share the link for the CSV? I will. So please use PPT or Notepad for teaching. I will consider that. Okay, sure. Please send me attendance link. Screen not visible clearly. Which one? Uh, okay. Yeah, I will going to put some CSV link here. Sure. Okay. All right. Okay. And now, honestly, Punit, like right now, this is all about coding. And I would rather tell you like how to do it instead of, just hovering over it with my pen and telling you like, this is it, and there you go. Now go home. Right. So, okay. And that is your df.describe. Now we have understood the problem as well. So we have also completed this data. Cleaning the data, let's say, like what do I mean by the cleaning the data? Okay, and let's see. Okay, cleaning the data actually comes in where we have some, let's check if we have missing values. Checking for missing values. Okay, let's see how. So let's say df dot is na dot sum. Okay, so we don't have any missing values apparently. Okay, so like any column, like in either of those columns doesn't have any missing values. Okay, so we don't really need right now any sort of cleaning. We will be needing the cleaning though, but in our next case study, but not in this one for sure. All right, it will be the most simplest one here. Okay, So it is also done. Now is the time for training the model. And training doesn't just, just it doesn't happen like that. Okay. In training the model, we like let me actually, split this into two parts. In training the model, you know, we first perform splitting the data in train and test. Okay. All right. And after that, second step, train on training data. And then comes this, fifth part. Then fifth part, we can actually literally write your fifth part, making predictions. So let me tell you, like, why do we need a training and testing data in the first place? Like, let's say we have this D data set, okay, D entire or D full data set. So why are we splitting this data set into two parts, train and test? What is the reason behind it, you might ask? Okay, so let's consider a scenario. Like in a real world, let's say you have been enrolled, like you have enrolled yourself into some sort of a coaching center for cracking an for cracking an exam, maybe for any international or national exam. Okay, so this coaching center environment, like let's say we have two environments here. Like in the coaching center, we have a coaching center here. Okay. In this coaching center environment, we have two environments here. The first one could be your training. Okay. And the second one, let's call it like, like let's actually, this coaching center will be only having a training environment. Okay. Training environment or your main examination. When your exam will be, held like on the D day, it will be having a testing environment. So let's see, like, what do I mean by that? Like, what exactly I want to pull it off here. So let's say on in this training environment, what you will be having, just imagine, like, the first thing that you will be having a lot of material, lot of information about the subject. Let's say it's math, right? So you will be given a lot of information, a lot of theories about how to crack that particular exam in mathematics. After consuming that much of information, now you may want to test it. Like, well, in that case, your coaching center might conduct some mock tests, right? So you basically appear in those mock tests. Okay, and after the test has been have been conducted, right? What you do, like, what you get a result, like you get a score afterwards. And let's say that score is around, like, let's say 80%. So in your coaching center, that particular environment was your training environment. You literally trained yourself for with a lot of information that your professors, maybe your trainers, maybe your teachers might have actually given you. After that, your coaching center conducted a few mock tests, and after those tests, you sit on, like you appeared in one of those tests and you scored 80% on an average. Like, let's say there were five tests and you scored around like 80% on an average. Now comes the D day, right? And what do I mean by the D day here? Now is the time to test your entire knowledge base, like whatever you have learned so far, like if it is applicable in the main exam or not, right? So in this case, obviously, like in this case, this process won't be there. Like, you won't be given any information about like what will be in the examination paper. There will be no mock tests. There will be final test and a score. And now let's, like, it actually becomes, like, right now it actually becomes somewhat interesting. So let's say on this one you score around like 75%. So what you will gonna say, okay, I usually scored in my coaching center, it was 80% test, sorry, it was on an average, it was 80%, and now I have scored 75% here in my main exam. So the coaching center environment was somewhat good. The information, basically this information is your data. That is your data. So the data quality was up to its mark. whatever you understood, whatever you was fed to learn, or make estimation about, whatever taught to, or whatever like whatever, like you happen to score 80% on an average, whenever whatever the kind of the data information you had. But that is the case, like this could be your case one, like case one, let's actually call it case one. Okay, and now let's say on the case two, let's say on the case two, what you do, like let's say on the training set, or I would say on the training environment, you get around, like let's say 95%. But on the testing set, what you get here, let's say like 40%. Now you will be infuriated at your coaching exam, like coaching center for sure. Like you will be like, like what kind of gibberish, or what kind of gibberish data set, or what kind of gibberish knowledge you may have consumed through those teachers, through those mentors. So you happen to score on an average 95%, but when it comes to real examination, you couldn't even crack 50%. Well, this is not a good case. Okay, all right. And now let's say case three. On the case three, we will be having a training environment again here, and the testing environment again here. Okay, on the training environment, let's say even after feeding you a lot of information, even after teaching you a lot of stuff that you might engage into, still you are not being able to crack more than 40%. And here you are only cracking around like 35%. So these are three cases which you are just like seeing, like this case, like when you have like such accuracy on scores, this is called a best fit. I will gonna come back to it. Best fit means like whatever you fed to your model, whatever you did, any kind of like training, it was good, because it the resultant for the testing data was also good. But when it comes to this one, like for this one, this is called overfitting. It occurred. Why? Because you really scored well on training data, or in your training environment, on an average 95%. So there could be, like, might be, that could be a chance, right? Like your coaching center might be giving you some easy stuff, right? Or maybe the tests were not up to that mark. Okay, therefore, like maybe like your coaching center generalized your entire examination paper way too way too simply, like way too simplified. So well, in that case, you happen to score well in the training set, but not on the testing set. Well, in this case, it is your overfitting. Okay, last but not the least, when you don't do like good either on the training environment, or not in the testing environment, well, in this case, it is your underfitting. And this case, like this is the worst case, literally you don't have anything here. Okay, so now therefore we need to actually we need to separate, or like we need to separate our entire data set into two parts here: training and testing. Okay, so we can literally check it out, like if our model is doing something good or not. Okay, so now let's do this. All right, I hope everything is clear to everyone. Okay, if not, please let me know. Can we have a quick recap again? Quick recap of what, Naga? Please let me know. It's for getting more accuracy of our model. मेरे को कुछ समझ नहीं आ रहा. Please let me know what part. Better take training. How to import CSV file in Colab? Just go here and upload it. That's it. That is how you can do it. All right. And afterwards, okay. So that is where we are here right now. Okay. So like where exactly we were. So now we are at like splitting the data. So let's split the data now. Okay. So we have like, even before splitting the data, we need to determine like which one are the features and which one, are not the features. So let's say like the features are X, or in this case, df dot drop species, right? Okay, and I will be dropping it from the axis, like from the column, like for the x is equals to 1. What do I mean by that? When I say x is equals to 1, it means the column value. Otherwise it will be a row value. Okay, and in this one, in this case, if we notice here, okay, here, in this case, this is your row values, obviously, and these are your column values. Okay, so for the column value, access value needs to be mentioned, which is in this case 1. And I'm dropping this column because I only need to train, like these are my features, because this is something I need to feed to my model, right? I will be feeding this to my model. Okay, and I will be predicting these values, so I need to have these values separately. So I will be calling x, and this value will be y. All right, okay, so let's somewhat scroll down a bit again. So yeah, so that is what I am doing here, and like, and y will be df of species. Okay, let's see now. If I do print x and print y, you can see for yourself. Okay, we have Satosa and Versicolor and Virginica, all of this. Okay, so what we have done, we have also splitted the data. Now is the time to training our model and then making a prediction. Okay, so let's see. So training the model. So how can we do it? So for the very first thing, okay, let's say I am actually importing a simple model here. It's not so simple, but I will not be getting into like the jargon or the main details of that model. It's an ensemble technique, which is a classifier. Just actually consider it as a classifier or a line or something, which will just going to determine, like, if a flower of a species is either versicolor, virginica, or setosa. That's it. Okay, so like let's import that model here. So how can we do it? From sklearn dot ensemble import random forest classifier. Okay. So this is a classifier, like the model which we just spoke about, like maybe in our last session. Like, okay, this is your model. Like this couldn't be like sorry, not here. Like this could be a model. Let's say like this could be a model. Let's say we have this data, and we have data in this format. Like this. Okay, and this could be your classifier. This is your classifier, guys. Okay, so this could be you can actually interpret this classifier as this value or this line. Okay, which will going to help us to determine if a flower of species is versicolor, virginica, or setosa. Okay, all right. Coming back here. So now, okay, now we need to instantiate this classifier, random forest classifier. Just go with the default values here. And now let's see, like, clf dot fit. This fit, we will going to understand about this fit a lot. Okay, this fit actually trains the model. Okay, and this fit requires two values here, features along with labels. Okay, so let's pass each one of those here. So I have, and as I mentioned here already here, what, like, we need to train it on our training data set and then test it on a testing data set. So let's train it on our train data set here. So yeah, so here we have our x train, and we have y train. Sorry, let's train it. What just happened? Oh, sorry, for my bad. Okay, now is the time, like we haven't split up our data set yet. So I will be splitting up the data set with the model selection, import train test split. So this does nothing but splits your data into training and testing set. That's it. X train, X test, Y train, Y test. Train test split. So it will be your X train, Y train, sorry, X and Y, and test size. We will be needing a test size, right? Like how much testing data we need. Okay, let's actually go with this. Okay, so now we have splitted our data set. Okay, like we are splitting like initially it was 100%, right? And now we are taking 20% out of it. So 80% we are taking as a training data set and 20% we are taking as a testing data set here. Train, and this will be your test. And we'll be training our model on this training data set here. Okay, so now let's come back here. CLF dot fit and X train and Y train. We have fitted our model, and let's make a prediction here. Let's make a prediction here. So let's actually create, or let's actually bring up a simple sample or simple, let's say like for the X test. Let's like this could be a sample here. Okay. Dot values. This is a sample, right? And like now I want to feed these values to our model and want to check like what we get here. So let's feed these values. Okay, so I will be naming it as sample. Okay, and now let's make a prediction here. Predict sample. Okay, what is it saying? Okay, so I think I need to reshape it in -1 and -1. So you can just reshape it -1 and -1. Oh, wait a sec. 1 and -1, sorry. Okay, so this flower species was of a Satosa. Okay, and if you do not want to do this, like it actually expects a 2D array here. So you can also put this value into a 2D array like this as well to make things simpler. Okay, so this value was of a Satosa. Okay, so what we gave here, we actually gave these values here. And based on that, those values, like we had, like, we predicted it to be Satosa. Let's see, like, if it is Satosa or not. So I'll be checking here with Y test of 0. So yes, it was a Satosa. Okay, so now let's check the accuracy. Like, checking the accuracy of our model. So how can we do it? Simply call cl.score x train, and y train. How much we can score on, like, it's 100%. So it's definitely doing something wrong because nothing is good with the 100%. And let's actually do with the testing data here and y test. It's 96%. So it might not be 100%. It could be like might be rounding off, like it could be 99.99 something. Okay, and this is 96%. So it's doing pretty well. It's actually doing pretty well. Okay, on training data set it is almost 99, and it's on here we have 97. So it's actually doing pretty well. Okay, so now like this checklist also have been like this part, this one, we have also made the prediction. So we literally checked all these like all these points to come up with this model what we are seeing right now. Okay, so that is your simplest machine learning task which we just performed. Okay, all right, and now I'm also done with this. So if you do have any questions, then please ask. Which part, like, please let me know which part. How to import, let me actually pop it out. Now I can actually take questions because I'm pretty much done with my coding and everything here. Okay, how to pop it out actually. Oh, there you go. Okay, pop out it. Yeah, let's talk now. So now people are asking, uh, uh, uh. So can you give the link of the CSV file? Okay. I can, what I can do, like, yeah, I will. Okay, just do check out the community tab and you should get that. uh, I already explained it's for getting more accuracy for my. Okay. What? Really? Let me know how. Do we have to remember all the libraries? No, we don't, and you should not. Uh, okay. Have a habit of Googling out. Or should I actually also take a session on how to Google? Should I? How to Google, or how to Google machine learning and how to Google deep learning? Um, yeah, Shriman, but just let me know how. Please show the commands again. Which ones? Yes, please let me know. Please do the post. Yeah, I will. Like, I don't know how can we learn then. Hit and trial as much. Just start off with, like I have already mentioned. I have already taught you how to tackle like that. That is actually simplest approach. Okay, and go again, like go over this video again, and again try to try it out on your own without copy pasting anything, and you'll be in a better place for sure. Okay. uh, I know it's not that like uh, that helpful, but that is actually the truth. That is actually the truth. To accumulate the data for this ML model, we use supervised learning. Yeah, that was actually supervised machine learning, guys. That was machine supervised machine learning system. uh, to accumulate the data. Sure. Accumulation of data is nothing but downloading the data. Yes. Okay. And this data, like what you else can you see, like just control S, and there you go. You have this iris data set here. Let me just put it here. Iris.csv is there. And what I can do now, okay, like what I can do now, like just upload this data. Okay. Like I have this iris, where exactly it is. There you go. Okay, iris dataset. Now it will be uploaded here. Okay. And after that, like, okay, now it has been uploaded. And now what you can do, you can just, remove this part. And now you can just call this iris.csv. Okay. And also what I can do, let's actually, restart it, restart the entire environment. Okay. And now, df.head, everything will just going to remain same. So now I'm using this, local data set here. So you can also do it without an issue. Okay, does that answer your question? Yes, let me know. Why did we use ELF? What do you mean by ELF, Naman? So can you give some practic? Can you give some practice model? What do you mean by that hidden circuit? And what do you mean by hidden circuit? Hidden circuit. Uh, okay. Hmm. Yeah, I can actually give you a simple practice question. Yeah, there you go. Okay, you can try it on Haberman data, survival data. Okay, here. So it has also a survival status in this data, and it's quite, like you have survival status here. So try to use this and make your own classifier. Okay, yeah, I will actually going to post it on the community. So do check out the community again. Come on, guys, that is it. Any questions? So why we choose random forest classifier algo other than any? Yeah, there is a okay. Okay, let me actually tell you. Random forest usually always does well if you are aware of ensemble techniques, right? Bagging and boosting. So they usually do well compared to its counterparts, like sorry, compared to its competitors like logistic regression, or maybe like naive Bayes does really well on text data. But yes, random forest in general always do better because it's an ensampling technique. Basically, takes the all the models aggregation in place. Like right now we are using decision trees there. That is why it is called random forest. So it has n estimators, maybe like 100 estimators are there. So instead of doing like decision tree one, like we can actually use 100 decision trees there to make single prediction. So it's more powerful. Why test? I don't know like how exactly you are getting. Yeah, please put your error in the community because I don't know like how to solve it here. Okay. Any more questions? Let me check you. Come on, guys, ask me questions. Last step. I don't know like how exactly you are, splitting the data. That is something I cannot tell. I can share my notebook for sure, which I will. Okay, so please do check out the community. Session was nice and clean. Thank you. You're welcome. Uh, all right, guys. All right, guys. So like sometimes my actually tongues actually. Okay, so yeah, please allow me to end this session now. Okay, and I'll see you around again tomorrow, very this time, and for the day three essential in machine learning and deep learning. Please do continue here. Explain the splitting. I have already explained the splitting. Please, no questions, sir. Thank you so much. Okay, all right, Shraddha. Thank you again. Thanks for the okay. You're welcome, guys. Whoever joined this session, so you're welcome, and bye bye. Take care and very good night. Bye. Thanks.